Hey, good afternoon. How's everybody?
Good afternoon.
How are you, Sophia? How are you, Ophelia? How are you, Gabrielle? All right. Yeah, let me quickly check. So, what is the latest announcement? What did I put in there? Oh, you have midterm, right? You have midterm. So let me share this with you. Okay. So you have midterm due this Sunday, and it's gonna start. It's gonna be available from tomorrow, 12 a.m. Friday. And please get a head start, right? I think I mentioned this yesterday, or not. Uh, if you wait until the last minute, and if something goes wrong, there's no response time. I can't do anything. Um, Again, if you start on Friday or on Saturday, and if something happens, some technical issue happens, and you would send me an email, and then I have time to fix it. I have time to fix it. Basically, usually it happens because of the loss of internet connectivity. Um, and If that is the case, I can reset it. But look, think about it. It will take it will take time for me to discover that email and respond to that. So if I have at least one day before, a day before the deadline, I can fix it. I can reset it, and you'll be on your way, right? I can put you back on the road. Um, and you have plenty of time to fix it. You have plenty of time to do it. And then uh, But if you send me an email, if this happens at the last minute, if you send me an email at the last minute, there's nothing that can be done, right? That's the common sense, right? And if you and some people, please don't wait, don't procrastinate, don't wait until the last minute, because I gave you 2 hours to do it, but most likely you can do it within 1 hour, or 90 minutes. Um, but some people start, like, 10 minutes before the deadline, or if you start at or 30 minutes before the deadline. If you start at 30 minutes before deadline, unless you're a genius, right? Uh, and besides, who starts 10 minutes before the deadline? That's totally, it's totally senseless. You get timed out right away. And then send me an email, "Oh, Professor, I got kicked out. I was in the middle of doing it. No, you started too late. You are timed out already. Then it's your fault. If it is your fault, there's nothing I can do. I mean, I won't do anything. I mean, I'm not. If it is your fault, there's no reason I would do anything, right? It's not your right. You don't have the right to extend. If the um, I gave you three-day window. When the 3-day window expires, then it's your fault, right? I don't have any reason or obligation to give you an extension. You had a 3-day window, right? So please get a head start. Um, and after that, everything is already pre-planned. So you don't, it's not visible yet, but there is, it's not visible, but it will be available August 13th, 12 a.m., which is tomorrow. And then quiz 2 is already, and quiz 2 will start on August 15th, right? So you better finish, up midterm ASAP and give yourself at least 1 day before starting on uh, the quiz 2. And then final, no, final's not going to be on the 19th, it's going to be 8th. So that's nothing new. I mean, I think I mentioned that yesterday too. So I want to finish up our example that we were working on yesterday, which is okay, this one is taking forever. Yeah, we were oh yeah, this one. So we basically we looked at how payment formula is derived from future value of annuity formula. So we now have this question. We had this problem yesterday, which is nailing the exact payment for your graduate school plan, right? Well, of course, we know through trial and error, we found 860 would nicely get you there, and it would overshoot. It will overshoot our 60K, the target future value, slightly by about $2. But if you want to nail exactly the full payment, yes, this is what you do. So we use the payment formula, right? Which is, I believe we did this yesterday, didn't we? Hmm? We did it yesterday. We just didn't. I don't know why it is not saved. If it, uh, someone did someone say anything? I heard some prompt noise. Okay, yeah, we did that yesterday. So yeah, but since it is not, it wasn't saved. Let me. Uh, so I guess we got started on the present value of annuities, right? Mm, well, let's do this. This times uh, R over 1 plus R raised to N is here minus 1. And of course, there's nothing there because those values are missing. So I'm gonna it's a matter of this we did it already. This is a different example. Okay, so I'm not gonna do this one. I'll fill it up anyway. This was a different example. What if What if it is quarterly, right? What if it is quarterly, right? What if it is quarterly, right? To reach, with 6-year time frame, 6.7 point. But I'm not gonna. We're gonna talk about, So we were talking about the yes, the lottery, right? Lottery is not a very good, as I said, lottery is not a very practical example. But if you won lottery, right? Out of what do you choose? I mean, if you pick lump sum cash payout, I said, you would get about 60% after tax, right? 60% of that's tax. So you get about 6 million. If you choose annuity, you get about 20,000 every month for the next 30 years. So there's going to be 360 payments of 20K. So the point is, we compare the present value with present value. So 60K is 6 million is already 6 million is already in present value. So we need to find the present value of all these 20,000. So this is the example. So I'm gonna, first we gotta find what is the periodic rate. So we divide this by this 0.5%, right? Multiply 30 years by 12 months, we get 360. And I'm gonna copy this up and down. The last one I'm not gonna do. You know why? The last one, let me drag it down, because if I drag it down, I lose that borderline. But then I can use I'll just draw the border. Oh no, not the. I have to reset it every time. So then, now we are ready, right? We're ready to. So, what will be the present value of all these $20,000? Well, using the this formula, payment over R, right? Minus payment over, open parenthesis, R times 1 plus R, and hit enter. Oh, you gotta close the parenthesis. And then it's 3.335 million. 3.335 million. So then if this is the case, what's your choice? Do you choose lump sum, or do you choose annuity? Anybody? Why is everyone quiet? I mean, is this difficult to is this a difficult question? Huh? Is this a difficult question? Isn't that quite obvious? How come everyone is so quiet? I mean, I have Abraham, are you there? Abraham, are you there? Abraham? Apparently not. Abul Hassan, Abu
Hey,
there? Abraham. Okay, so you just, why? Why such a delay? I already, Abul, are you there, Abul?
Yeah, can you repeat the question?
The question is, we found the present value of all those annuities, and it came to this. So what is, why are we doing this? What's the question? The question is, you won the lottery, right? Remember? You won the lottery. So if you choose lump sum, if you choose lump sum cash payout, uh, you get about you get 6 million. But if you choose lottery, if you choose annuity, you get 20K every month for the next 30 years. So because you cannot compare directly 6 million with this, I've been telling you, because it's 20K every month. If you think that's, oh, 20K times 360, oh, so that must be 7.2 million. No, if you think that's that way, I've been telling you that's wrong, because that 7.2 million doesn't exist anywhere, at a single point in time, right? It's simply, so the only way you can compare these two is by converting everything into present value. Now, 6 million is already in present value. It's already today's 6 million, right? But this 20K is spread over the next 360 months. So then you need to convert this into a present value. So we use the present value of annuity formula for that, right? So if you do that, we came to this result. So then what is your answer? I mean, do you pick the lump sum or do you pick the annuity? Do you choose lump sum or do you choose
Isn't the
annuity?
lump sum, wasn't it 6 million?
You choose lump sum, yeah. And who said that?
Well,
Abul. Okay. So you got 0.25. Yeah, you choose lump sum. Why? Lump sum 6 million is already in present value. This is the present value of all those $20,000 over the next 360 months, every month, right? But again, you would have soon realized that the present values all depend on what is the discount rate, right? Because if the discount rate goes up, if the discount rate is high, think about it. When this goes up, right? If the discount rate goes up, what's going to happen to the present value? If the discount rate goes up, what's going to happen to the present value?
It's gonna decrease.
It's going to decrease, yes. And who said that?
Sophia.
Okay, Safia again. Safia has 0.25. Yes, of course, this is just the logic, right? It's just the logic. And if you have hard time, grasping this logic, then that's, it's a problem. It's a big problem for someone, for an adult. Not getting this logic is a, dead end, because payment is given. It's right. Payment is given, so it's a constant. It's not going to change. It's 20K. Then the only factor that will affect the present value would be, there are two, interest rate or the time, right? Also, as time goes on, as time goes up, okay, as time goes up, right? The thing is, we all know that. So let's separate it. first we think about only when interest rate goes up, discount rate goes up, this goes down. On the other hand, when rates don't change, but time increases, what's going to happen to present value of annuity? When time increases, when time goes up, what's going to happen to the present value?
It also
Anyone?
decreases.
It also decreases.
Yeah.
It also decreases? Why?
But because the denominator increase.
Denominator, but denominator only in this term. You're right, when denominator goes up, the fraction goes down, but n affects only this. You understand? N affects only this. So only the second term goes down. Only the second term goes down. So what's gonna will n affect this one? No, this term is independent of no. So then what's gonna happen to present value?
It goes up.
It goes up. Okay, it goes up. It's a little different in single cash flow model. Let's go back to single. If we are talking about single cash flow model, right? Then either way, I mean, even when discount rate goes up, present value goes down, right? Because the denominator goes up. Also, when n goes up, present value goes down. If it is single cash, right? But if it is annuity, when n goes up, present value of annuities go up. Why? Also, think about it. Let's intuition. Let's think about intuitively. N goes up. What does that mean? You are getting more annuities, right?
More.
I mean, not 30 years, 50. I mean, you're getting 100-year annuity. Suppose you are getting a 100-year annuity. Unless interest rate goes up, and unless interest rate goes up, and assuming that interest rate remains the same, constant, payment is always constant. But with how many, if you're getting 100-year annuity, obviously that is worth much more, way much more than 30-year annuity. Does that make sense?
Yes.
Right. Okay. So that's why I'm gonna. So looking at this, and we know the reality is, the prevailing market rate is not 6%. This is something like in an ideal universe, right? Reality is that we don't even get 1% on CDs, right? We get probably 0.5% on CDs, 0.75, But so we can tell what it's going to be like. The reality is more like this, 1%, discount rate. So then we try that. We don't have to do it again. We'll just, drag it down, and there you go. If the rate is 1%, then what's your choice? Do you take lump sum or do you take annuity? How come everyone is silent?
Lump sum.
You still take lump sum?
Oh, no. Okay.
Annuity, this
So
case.
You choose annuity because
It's larger.
if the discount rate is lower than like 1%, we end up with present value, which is greater than 6 million, then you go for the annuity. And so this is more like the reality, because currently the prevailing market rate is not even 1%, right? What about, yeah, and this, if it is 20 years, right? I mean, 50 years time. So you won the lottery, and if you won the lottery, and you get like $12,000 every month, but for 50 years, then what would you do? Well, again, if the prevailing market rate is 6%, it's only like this, so you go for the lump sum, right? If prevailing market rate is 1%, this is the present value. Still, you go for the lump sum. But what if, if it is 50 years, if the time annuity period is for 50 years, maybe they're not going to give you 20,000. They may give you just 10,000. Oh, still, if it is 10,000, it's worth much less. Maybe, what about 15,000? Let's see. Oh, if that's the case, you definitely go for the annuity, right? If that's the case. Okay. All right. So then let's think about this one, right? The first example, we haven't even done it yet. So what is the first example about? So let's take a look at the second scenario, right? So you consider financing a $30,000 car for 5 years with 20% down. What does this mean? Yeah, you're buying a car, but you finance it. You borrow money. Of course, you have to make a down payment. So if you make a 20% down payment, then that's 6,000, right? 6K. Then 24K, the balance. The 24K is the financed amount, right? That's the loan. And you will, if you haven't bought a car yet, in the future you will. The way it works is, you might wonder, oh, so I must, I must first find the bank lender first, and then get a loan and go to the car dealership. No. Just go to the car dealership, and at the car dealership they connect you, right? They arrange the bank, right? Most car makers, most automakers have their own bank that specialize in financing the cars that they make. So Hyundai has Hyundai financing. General Motors, GM has, what was GM had, their own, bank. That was called what? Actually, it was like, I forgot the name. Chrysler has their own financing arm, their own bank. So basically, those car dealerships, automatically arrange that the loan with some bank. I mean, so you don't have to worry about it. But then the question is, okay, so 24K is your loan, that's your borrowing, right? And currently the market prevailing interest rate is 6%, meaning this is your interest rate. You borrow that 24K at this interest rate, and the dealership says that your monthly payment is $500. Okay, so in your mind you do a quick calculation. It's called back of the envelope calculation. Back of the envelope. You just do the calculation on the envelope. Okay, 500. So for the next 60 months, right? It's 500 times 60. So it comes to 30K. Well, then I only owe 24K, so that's the principal. That's 6K must be my interest. But then think about it. If it is 6K annually, right? Even just by back of the envelope calculation, right? If it is 6K, 6%, I'm sorry, 6% of 24K, right? Just if you do that, and that for 5 years, I mean, just a simple, very, let's say you don't know anything about, compounding. You don't know anything about time value of money, but still, even by simple interest method, right? 1 year interest is 24,000 times 0.06, and if you do that, 1,440, right? Or then for 5 years, oh, that's already, times 5. Oh, then that's 7,200. So I must be saving on interest. No, that's wrong. You can't. That's not the way. Because why? As you're making payment, your principal is going down. So as the principal goes down, the interest doesn't stay the same, right? Interest doesn't remain the same. So anyway, the point is, if they told you $500 is your monthly payment, then obviously there's a big question mark. Is this the correct payment? Is this the correct payment? How do you know if it is the correct payment? You can tell if it is the correct payment by finding the present value of all these $500. You understand? These $500 are these $500 is the annuity, right? Monthly annuities, right? So there are 60 of them. If you find the present value of all of them, and if it is equal to, what must it be equal to? What must the present value of all these $500 be equal to? Anybody? What must be the present value of all these $500 be equal to? Anyone?
30K.
30K? No. If it is equal to 30K, then if it is equal to 30K, then that's exactly the price of the car. But you didn't look. You paid 6K. You already paid 6K as down payment. You borrowed. You borrowed only 24K.
Is it 400?
The loan principal.
Is it 400?
What is 400? I mean, are you saying present value of all this $500 must be equal to 400?
Oh no, I misheard your question.
My question, look, you answer the question as exactly as it is asked, right? I don't know why people have a hard time answering the questions the way it is asked. The question was, what must the present value of all these $500 be equal to? Again, think about it. If it is if you're making $500 payments, and there will be 60 of them, right? Because it's 5 years. Then I told you, by the I don't know. I explained it in a very easy way, and some people still if you think what you owe is 500 times 60, then you are dead wrong. Why? Because it's just the total of all those $500. I mean, of course, if you multiply it by 60, it's going to come to 30K. But then Your loan principal is 24K, not 30K. Huh?
I just want to say,
Your
is
loan
it
24K?
principal.
24K?
Because you already
What?
paid 6.
Did someone?
I,
What did
I
say?
just want to say, is it 24K because you have paid the down payment, which
Yeah,
is
I was
Yes,
gonna say.
yes. The principal
6K?
is 24K. So one person at a time, please. The principal is 24K, loan principal. So what must is the present value of $500 be equal to?
At least 24K because you already paid
Yeah,
6.
24K. It must be equal to exactly 24K. You understand? Why? Because if this is the correct monthly payment, right? And this has already interest built into it, right? Because every monthly payment must have portion of the part of the principal, right? It consists of every monthly payment consists of interest and principal, and it's not in equal proportion every month. You might think, every month, it must be in equal, like, out of 500, 400 must be principal and 100 must be the interest, and it's going to be like that all the time. No, the composition of principal and interest changes every time. And early on, it's mostly interest, and as time goes on, it's interest gets smaller and smaller and smaller, and principal portion gets bigger and bigger and bigger. Okay, that's called amortization, but I'm going to get to that later. The point is, so since if this is the correct payment, right? Present value of all of these must be exactly equal to 24K. Okay? And some people, then even after all this, some people still ask, what about the interest? I've been telling you, interest is already built into this. Every monthly payment, interest is built in. So who said 24K?
Yin Yu?
It
Loud,
was
please.
Sophia.
It's your credit. Who said that?
Yin Yu.
Inyu.
Sophia.
Okay.
At the
Yeah, I
same
think
time.
at least there were two people. So, okay, Inyu and Safia. Okay, you got 0.2. Yeah. You shouldn't be timid when it is, your credit to claim. You understand? Otherwise, somebody else takes your claim. Somebody else takes your credit. You better speak up, speak loudly, and enunciate your name, right? When it is, your credit to claim. If it is your credit to claim. So we can check it. I mean, if this is the correct payment, the present value of that, and then if the so let's first find out. And it's nothing new. We just simply, because we have already done it, we simply go. And then what is that? Oh, the present value of all those annuities are greater than 24K. So that means you are being ripped off. You are overpaying. You're being ripped off, right? So it's basically, so you can come to a conclusion if the present value of all those annuities, there are three possibilities. It can be greater or equal to or less than 24K in our example. So if it is greater than the loan principal, which is 24K, you're overpaying, right? You're being ripped off. And if it is equal, then that's correct. If it is less than 24K, you're actually ripping them off, right? You're ripping if this happens, this is a good deal for you. But, of course, it's not going to happen. But by any fluke, if this happens, it's a very good deal for you. You are paying less than what you owe, right? The present value of all those annuities. So think about it. Of course, you know, unless there's a glitch in the program, it's the program used by the bank, so it will be exactly equal to 24K. But by some, you know, fluke, something like this happened, you know, the present value of all those annuities are greater than 24K. What do you do? If that happened, what do you do? Nobody. They are ripping you off. So what do you do?
Pay at once.
Find a new loan system, like find somebody else to get the loan through.
Why do you go through that trouble? This is a time to call your lawyer, don't you think? Huh? This is a time to hire a lawyer, right? And they will look. This is gonna be a big, you know, case. You know, a big automaker like, you know, GM, Chrysler, or, you know, Ford, or, you know, whatever. Of course, you know, then they will say it's the dealership, you know, that made a mistake, but because of a glitch of a program, then they will correct it later. But, you know, there will be some kind of, you know, there will be a compensation, not just, you know, paying, refunding you for that overcharged portion, but there will be some kind of, you know, compensation, right? Because it's a bad publicity for them. Now, of course, you know, you will keep quiet if this is the other way around, right? If, you know, 20 present value of all these annuities are less than, you know, loan principal, I'm sure you're gonna keep quiet, right? They will. It's their fault that they haven't, you know, right? So you keep quiet until they discover it. But anyway, so that's one way you can check. But another way you can check is, look, you can nail the exact payment too, right? You can nail exact payment, right? Just like we did. So basically, we rearrange this formula, right? And then factor out the common factor, and we can solve it for payment. In other words, maybe you have seen before that, you know, this is the formula I gave you, but, you know, also the formulas that you can find on the internet, they may look a little different. You know, for example, for payment, they give you a formula that looks quite much more complicated. It's look, in the denominator, the fraction is on 3 levels. The fraction is on 3 levels. That alone is a so don't go by this. I mean, it's the same formula, but, you know, just arranged differently. Same formula arranged differently. But, you know, this is so it is so you know, look, it looks more, you know, cumbersome. But actually, you will realize this is, you know, 1 over I minus, right? Isn't that right? 1 over I minus 1 over, so multiply payment there. Payment over I. I is R. You know, they use I here. Payment over R minus payment over R times 1 plus R to the n. It's the same thing, right? And that's the present value of annuity, right? And for payment, I don't know why they put the they put future value of annuity first, and then, you know, here for payment they put the present value of annuity first. The point is, don't bother with this because the they arranged it in a more complex way. This one is much better, but if you rearrange this, think about it. It will look like, what is the common factor here? Common factor is, you can say, oh, is payment over R. Yeah, if it is payment over R, if you factor it out, this term will be 1. This term will be 1, and this will be 1 over 1 plus R to the n. But although we can do it like that, but we will factor out only payment. If you factor out only payment, what's it going to look like? If you factor out only payment, ignore this, ignore D, it's annuity due, but so ignore this, but look at only okay, snapshot. So I'm gonna put it here. Oh, what's going on? Okay. Then what I can do is I can use draw pen. So I must have explained this yesterday, because annuity due has one more compounding always. Annuity due has one more compounding. So this is annuity due. So let's ignore this. Ignore this. Okay. If you ignore that, then this is just ordinary annuity, right? Present value of ordinary annuity. And how did this become this? It's just, I factored out payment, right? Because it's a common factor. Then inside, I will have 1, because this will leave 1 over R, because I factored out payment, 1 over R. And this one will be 1 over R times 1 plus R to the n. But then we find a common denominator, right? Because R and R times 1 plus R to the n can be unified. How? By multiplying 1 plus R to the n to the left hand, to this term, by multiplying that by 1 plus R to the n. Now, and you remember, when you multiply 1 plus R to the n to the denominator, you have to do the same thing to the numerator. And the numerator, after factoring out payment, it was just 1. So then the now we can combine these two terms, and with the common denominator of R to the R times 1 plus R to the n, right? This term, numerator in this term, which one will become 1 plus R to the n, because you have to do the same. You have to do the same thing to both numerator and denominator. And this one, nothing to change in the denominator, because it was already R times 1 plus R to the n. And it is 1, the numerator is 1, because we factored out payment. So this is the formula. I mean, this formula rearranged, and it looks like this. And then what is this? Remember, it is already z equals x times y structure, isn't that right? And I've been telling you over and over, all equations, no matter how complex, as long as you can identify z equals x times y structure, then you can solve it, right, any way you want, right? So you must reduce it to the simplest form, right? You must reduce it to the simplest form. And therefore, Now we can solve this form. We can solve this for payment, right? And if you solve this for payment, right? Of course, it's going to be z divided by y. So it's going to be PVA divided by this thing, the thing in the bracket. But dividing by a fraction is the same thing as multiplying by the reciprocal of the fraction. So eventually, the reciprocal, this thing raised to -1, the reciprocal is then what? R times 1 plus r to the n over 1 plus r to the n minus 1, right? So everyone is clear about that now? Everyone is clear about that?
Yes.
I don't hear anybody, so nobody's clear about that, huh?
Yes. Yes.
Okay, good. At least one person is clear about that out of all these people. Okay, what's in the chat box? Okay, Ophelia. So what does that mean? I mean, what's your hand? What's your hand? Is that confirmation? Is that the confirmation that you are clear about that? Is that the confirmation? I don't hear anything. So, oh yeah, thank you, Ophelia. All righty. So back to our problem. So we can nail the payment directly. So if you are nailing the payment directly, so I'm going to have to change this to 24K. And then everything else is the same, 24K, right? Then we'll do that. We'll use that formula. And the formula is PVA, because the correct, if the monthly payment is correct, then present value would have to be the original 24K, the original loan principal, right? So, and times R times 1 plus R raised to n divided by, open parenthesis, and another open another one, 1 plus R raised to n minus 1, close parenthesis, for the entire denominator, and hit enter. What do you get? Well, you get, yeah, that's the correct payment, 463.99. That's the correct payment, right? It's the correct payment. So that means, you've been almost, 464. So every monthly, you have been ripped off by about $40 monthly every month. I mean, if you have discovered it only much later, then you have been ripped off a lot. But if you have, discovered it early on, then the present value of annuity can be used, it can be very useful because, in the old days, before the days of, days of computer or, financial calculator, it was not so many people were able to, if there was any fishy business, I mean, if you went to the car dealership and they did, because without the computer in the like 1960s, 1970s, no personal computer, no laptop, not to mention even laptop, and no financial calculator, and generally people with no lack of financial literacy or financial education, financial training, they would have to take the dealer's word for it. So you would never know if $500 was a correct payment or not. And in those days, they only had a table, the interest factor table, and nobody carries interest factor table. It's only with the at the mortgage broker's office or a bank. Now, but since like 1990s, with the laptop, laptop became quite affordable since late 1990s. I mean, early 1990s, laptop was still like a status symbol. 1992, I remember 91, 92, laptop was like $5,000. There was laptop, really. It was laptop. And it was, it looked like a lunchbox because, it was the size of the lunchbox and thickness of the lunchbox. So it was at best, 8-inch screen. And the best thing you could do was just, and it was running on DOS. There was no Windows until 95. There was no Windows. It was running on DOS. So black screen and just white font. You just all you could do was just typing. Typing up word processing. But it was like $5,000 in 1991, $92. But since late 1990s, laptops became very affordable and running on. So whenever I went to the car dealership to buy a car, I always took my laptop with me, and when basically negotiating the deal, I opened up my laptop and opened up my Excel, and I entered all this, and then what's my interest rate, and I know I have a very good credit score, so I get the best interest rate, and 5 years, 60 months, I could do that. And the minute I did that, they panicked. And then I stand my ground. This is the correct monthly payment. If this is not, I make this down payment, and if this is not the price, and if this is not the monthly payment, then I don't buy. There's no business. I'm walking out. And then they have to succumb to my demand. The deal, I cut out the deal to my likings always, because as a consumer, as a buyer, you don't have to buy if you don't like it. They are at the and some people, and a lot of people with no finance training in finance and economics would just have to take their word for it. If they say $500 is your monthly payment, you'll have to believe. You'll have to take their word for it. You'll just have to rationalize. You don't know if it is the correct payment or not. Of course, it's not only this. There are other factors. Like tax rate, what fees they charge. There's doc fee. There's there are like a couple of fees. At least 3 types of fees that go into, and then the DMV fee, and the license plate, but anyway, after all that, you can always subtract it already from your down payment, and so your net down payment, you can, all you need to know is what is the loan loan amount, and you can do this. And if they are saying anything other than that, then you can just take your business somewhere else, right? You can always, and they are the ones who have to sell, right? Most of the times it's the buyer's market, right? It's not the seller's market these days. The demand has gone up. Even the used cars are selling at like 150% of their market value, and that means supply is less than demand. So then it will be a seller's market, but most of the time it's the buyer's market, right? So anyway, if you understand this. Now I want to just close up, collapse these. Oh, what did I do? Hide those rows. And the next thing, I'm gonna build amortization schedule, and so I want you to. I believe you have been doing this with me, because if you don't have this file open in front of you, and if you're not doing this with me, then you are basically losing a lot. You are, just wasting your time. So before amortization schedule, what is amortization? Amortization is another name for paying down your loan. Amortization means, amortize. That word, where did that word come from? Obviously, some people, when I ask this, some people say, does it come Spanish word amor? No. Why does, I know in amor, that must be love, right? That's in many languages, also in English, amorous, right? French, amour, amoureux, right? Amorous, right? But then that is, quite ridiculous. What does the paying down of debt have to do with? Oh, how do I get rid of this? Okay, okay, right. Actually, the word, actually, if you think about it, it comes from the this radical mort, right? Which is, which means, of course, the radical, the etymology of the radical is Latin, but in French, mort, dead, right? Amortization, amortize, that means, bringing death to the debt, right? You bring the debt to its own demise. Okay, so amortize, right? Amortize. And then the amortization looks like this. I mean, this picture, this diagram to the right is showing you the way your loan principal declines. And what are these yellow bars? Well, yellow bars are monthly payments. So yellow bars represents monthly principal and interest payment. And you might wonder, oh, monthly payment is like $700, right? And early on, look, this yellow bar is interest. So the green bar is the principal. So the early on, it's mostly interest. And as time goes on, interest gets smaller and smaller, and principal gets bigger and bigger and bigger out of this $700 monthly payment. But then, what is the amount of loan? 251,000, almost 252,000. This looks like a mortgage loan. 360 payments, 30 years. So it looks like mortgage, But then, doesn't it make sense? I mean, this is 252,000, and that's at the height of the loan principal, loan principal balance. At the height of the principal balance, that's this, but that's the same height as $700, same height? No, of course not. So how is it possible? They are using two different axes. You understand? we have two vertical axes. We can normally, the vertical axis is put here in the left side, and the horizontal axis is always at the bottom. But what in this graph, the loan principal balance follows the left axis, left vertical axis, and the payment follows the right vertical axis. So the units are different on both axes. Do you understand? Does that make sense?
Yeah.
Okay. So in the left vertical axis, this level, this level here is like $250,000. But on the right vertical axis, somewhere here is like 500, and here is 700, right? So it's you have dual axis, and they are on different units, different levels. Okay. So, but the point is, then as time goes on, early on, the loan balance decreases steadily, but gradually, but slowly. But after a certain time, it accelerates. How do you know? The slope is getting steeper. The slope is getting steeper. You understand? Slope is getting steeper. In other words, the rate of decay is increasing. Early on, the slope is flatter, not flat, relatively flatter than here. So the speed at which the loan balance is decaying is slower, but as time goes on, it gets, loan balance is decaying at a faster rate. So this is called amortization, because think about decay. Eventually, what is the end of decay? Huh?
Death.
Death, yes. Yeah. That's why amortization, you all know what mortal means. Mortal, you know mortal only through Mortal Kombat. Mortal. It's inevitable that people die. Any living being, it's inevitable. They are all mortal. You're not immortal. You're all mortal. Mortician. Why is it called mortician? Because they are funeral directors. They are morticians. And mortuary, right? Mortuary, right? Mortality rate. Mortality rate. All of these. So that's what amortization is all about. So let's do the amortization schedule. Basically, this will tell us there are two things that the amortization schedule does. One, it breaks down our monthly payment into interest and principal. And I've been telling you, it's all different every month. It's going to be different. You saw that also. Every month, the composition of interest and principal changes, varies, right? Second, it tells you what is the principal balance, after every, right? So you would know so first, I want you to clear out everything here. I want you to clear out everything except the last row, because in the last row, I already entered, auto sum command, sum command. So it's gonna sum everything as we move down. So first of all, payment number, right? You enter 1, 2, 3. Basically, it's telling you don't have to put every 1 through 60. Just put 1, 2, and 3. And Excel is so smart. It's smarter than you think. It takes a correct guess at your intention. Your intention is you're gonna because it's obvious. You are going to generate a series of numbers, and the numbers have interval of 1. And the numbers are all integers, and they have interval of 1. So Excel understands. So if you highlight those, select those 3 cells and drag it down, Excel generates a series of numbers that are, that have right interval of 1 between each number. And as you drag it down, you will see on the right side, you see a small box with the number of rows. And when it is 60, you stop, and it's going to generate 60. And then first, let's put in the payment. And before I do that, I wanna do something, which is, if you go to view and you can freeze panes. If you freeze pane, what that means is, as you scroll down, if you scroll down normally, the whole screen moves up, so you lose the labels, and you lose labels. You're not sure what column you're in. But if you freeze pane, you will never lose the sight of the labels. Also, to the right, no matter where you go, you never lose the row, the labels in the row, in the column A, right? So here, in the first month, right? Any month, think about it. Payment is always 463, right? It's gonna be the same amount through and through, right? So what do you need to do? If you enter it, and I'm gonna drag it down, but if I drag it down just like that, it's not gonna be pointing to this, right? Because as I drag it down, it's gonna also reference will move down by reference to cell will move down by 1 row every time. So what do? I will hit F4. If you hit F4, then it's going to lock, right? I'm locking into this cell, right? By that $sign, that means, you're locking into column A. You're locking column A, and you're locking row 23. So then this cell, A23, will be locked. And then as you drag it down, it's going to be always A23. Okay. So then sum of all those monthly payments will come to this. And interest paid, what's the interest rate? What is the interest rate? Anyone? Every month, what interest rate? Every month, what is the interest rate that applies every month?
6%.
If you, huh?
6.
No, 6 is annual rate.
120.
What do you mean 100?
100.
100%?
120.
What are you talking about? I'm asking you interest rate.
Oh,
Every month.
sorry.
Is it 0.05?
0.5, right? 100 is not a rate. You mean 100%? You're paying all 100% as interest?
Oh, no,
So-
I mean interest payment.
Okay, and so who gave me 0.5%? Who gave me 0.5?
It was me.
Ophelia.
Ophelia? And who else? Ophelia gave me 0. So
I
Ophelia
gave
gets
you.
0. And who is that?
It's Abraham.
Abraham, okay. So Abraham, you get 0.25 too. Yeah, every month it's going to be 0.5%. So I'm going to also lock it because that has to be. And I'm paying 0.5% on what? When you're paying interest on what?
On top of your
Your
principal.
principal.
Your principal, yes. And who was that?
Sophia and Abul.
Sophia?
And Abul.
Okay.
Thanks.
I don't know if Abul said the same thing.
Yeah, he said it at the same time as I did.
Well, I couldn't hear it. Okay. And I don't know. I mean, he could have said the same thing, but he could have said different thing. So I can only, I can only give credit to what I heard clearly. Okay.
It's fine. Give it to Sophia, so it's okay.
Yeah, Abul. I'm sorry, but because there's no way I can confirm, whether I didn't hear it clearly from you. So this time, I'll have to. You'll have to take a pass on that. Now, so what is the principal? What is the principal at in the first month? What's the principal?
$463.99.
No, that's not principal.
24,000.
Yes. Who said 24,000?
G-Quan.
Ji-Quan. Yes, Ji-Quan. We get 0.25. Ji-Quan. Yes, that's the principal in the first month. Think about it. At time 0, before you make any payment, right? Your principal balance is exactly 24,000. So, yeah. And that's the then that's the interest in the first month. Then what is the principal paid? What's the principal paid in the first month?
The first payment, so $463.99.
Say that loud, please. Speak it up.
The first payment, $463.99.
$463.99. That's the principal paid. If you said $463.99, then that's wrong. That's monthly payment. And don't you understand? Didn't I tell you monthly payment consists of both principal and interest? I mean, here, didn't I tell you out of monthly payment of $700? Yeah, that's $699. The yellow bar is interest. The green bar is principal. So what does that mean? Monthly payment must break down into interest paid and principal paid. Isn't that right? But we already know what is the interest paid, so what should be the principal paid?
$343.99.
Don't give me the number. I don't know. You give me the logic.
Oh, B29 minus C29.
Yes. It's the payment. The difference between the two is the payment minus interest paid. So obviously the difference between the two must be the principal paid. Isn't that right? Was that Sophia?
Oh, yeah, that makes sense. Yeah.
Okay, Sophia, you got, another 0.25. Then, after making this payment, what's going to be the principal balance? What's going to be the principal balance?
Minus the principal paid.
Say it out loud. I can barely hear you. Why can't you speak up?
24K. Can you hear me now? 24K minus the principal paid for the first month.
What? What did you? 24, what? 24,000?
24K. Yes.
24K
minus
minus?
the principal paid in
Yeah,
the first
the
month.
principal paid. Yes, because before making this payment, the principal balance was this. So the principal balance will go down by exactly by as much as principal paid. Okay? So this is going to be the new principal balance. Now, from the second month, let me just, this is not right yet, but let me just drag it down just for, and then let's think about it. What is wrong here? Interest paid in the second month, 0.5%, that's correct. But what's G24? There's nothing in G24 because I deleted that, and I collapsed. Look, from row 23, then it jumps to row 27 because, I collapsed, those rows and there were nothing there. There were nothing. So it's pointing to nothing, 0. So that's why it's, 0, nothing there. But we know in the second month, or at the beginning of the second month, the principal balance is what? At the beginning of the second month, what is the principal balance?
What you had before in the one above.
So what is that? What is that? What you had before?
Is it E29?
E20, E29.
Oh, who said?
Yeah.
Yeah. E29. Yes. Who said E29?
In you.
In you?
In you. And I also think there is another
and who else?
also said that.
Who said E29? I heard at least 2 voices.
Sophia.
In you and? Well, that's fine. If you don't want to take credit, that's fine. And I also heard someone giving me the number 23656. I heard something like that. Who gave me the? But don't give me the number because.
I'm the actual number. I can't think.
And who gave me that number? It was a guy. I heard a male voice. Who gave me that 23 something? You don't want to take credit, then that's fine. I can't, we can't waste too much time on, dwelling on that. So, yeah, in the second month, because the principal balance is this, then at the beginning of the second month, this is the principal balance. So that's the interest. Then the principal paid is the difference between the two. And then, again, principal balance at the end of the second month will be, now, I told you, G24, there's nothing. And at the beginning of second month, the principal balance was what? What was the principal balance at the beginning of the second month? Huh?
E29.
Yeah, E29, right? It was E29, and it goes down exactly by D30. Okay. And then, so who gave me that E29? Who gave me the E29?
G-Quan.
G-Quan, okay. You get another 0.25. All right. From here on, it's piece of cake. It's just walk through a park. You just highlight these 3 cells and just drag it down until you reach, row 60. And then, how do we know if this is correct? We know it's correct because when look, at the end of 60th month 60, the principal balance must be 0. Isn't that right?
Yes, because you shouldn't owe anything else.
Yeah, because you have paid back all the principal,
Everything.
right? So the principal balance must be 0. So that's correct, right? And then let's take a look at this column, and it's the sum of all the principal paid. And look, sum of all the principal paid must add up to, I mean, that already, sum means that all the principal paid must add up to 24K. Isn't that right?
Yeah.
Isn't that right? Then it adds up to 24K. They add up to 20. And what about, and the payments, we already got that, sum of all those payments are 27K. And look at the difference between the two. Difference between the two is exactly 3,839. The difference between the two is exactly 3,839.
The interest paid.
839, I'm sorry, 3,839. Isn't that right? And which is exactly the sum of all the interest paid. Right? So this way, you build the amortization schedule. And if you build, right now, it may take you, It may take you 5 minutes or even 10 minutes, but once you get the hang of it, this is like 20, you can do it in 2 seconds. Of course, you have to, build this, you have to architect this, right? So it may take more than 2 seconds, but, but something like 20 seconds or even, 1 minute, you can build amortization schedule like this, okay? And then, uh, as I said, it serves two functions. One, you can, it tells you how every month, in the 10th month, right? You make the same payment every month, but how it breaks down into interest and principal, right? And then suppose, after 12 months, this is the principal balance. So you know how much you have to pay to buy out the car. In other words, you want to pay off. You want to pay off. So all you need to do is pay off the remaining principal, right? You understand? Because you're paying off. There's no more interest, right? Because obviously you're paying off the principal balance. Why? There's no interest you have to worry about. Of course, in reality, the payoff amount will be slightly more than that, slightly, but because of some transaction cost, right? Some administrative cost and things like that. But it won't be very much different from this principal balance. It would be about $5 more or $10 more, right, for administrative cost. But then pretty much you will know what is the payoff amount. Okay, so everyone is okay with that? Everyone is cool with this? Everyone is okay? Did everyone get the same result?
Yeah.
When I demonstrated this, I did it with, for you to follow. So did you get the same result? Did you replicate it? Did you? And you got the same result?
Yes.
I don't hear it from anybody, huh?
Yes.
Okay, good, good. So, so think about it. There are, let's see. We didn't talk about the effective rate, but again, I'm going to talk about the effective rate. But everything is all, explained in the original lecture. It's all explained in the original lecture. And I want you to also, the midterm is actually covering, midterm is covering the financial statements and time value of money, right? Midterm is, on those two topics. So you need to review what we did about the financial statements, and also there are not every problem is as straightforward as these examples. So I want you to I want you to review. There are yeah, future value of multiple annuities, right? This is something, I mean, if you have time, you also, my concern is that, as I said, since quiz 2 will be, following right after the midterm, quiz 2 will be following, and the quiz 2 will be on the bond valuation and bond valuation, and risk and return, topic 4 and 5. And we haven't got a chance to review these, but the main lecture has already, been delivered, right? And as of today, you should be done all the way up to this, right? Why is it like this? Today is the 12th, and why isn't that? Okay, this was the problem. So I want you to study thoroughly, so this weekend you must, finish, midterm ASAP, and give yourself some time to study for bond valuation and risk and return. And because it is starting, okay, when, again, quiz 2, it is not in the announcement, but it's gonna go out on August 14th, the Saturday. It's gonna start on Sunday the 15th, right? You'll have until Tuesday, 3-day window. So if you're all caught up all the way, if you're all caught up to if you're all caught up all the way to this, right? All the way to this, then you won't have any, you won't find it very difficult. Another thing, some of the oh, good. They are still, all these videos are still active, so good. All these videos are still active, so good. But by this weekend, it may not be anymore. But then again, you have, my YouTube, not this one, my YouTube channel, fnb100, right? There are 60 videos there. Everything is there, right? So you can always, everything is there. You can always, go back and refresh your memory. Okay? Bond, risk and return. Okay. All righty. So, any questions? We are, someone says 0.5. That's Ophelia. Ophelia, you got, yeah, Ophelia, you got 0.25 for that answer, right? That was at 658 and 720. 720. All right. Any questions? I think we will stop here. And if you have completed this amortization schedule yourself, I think you're good. If you haven't, please try it out and ask me questions now, because this is the last chance before the midterm, and also before the of course, Monday you can still have a chance for question for quiz 2. Any questions? You're very quiet.
Just wanted to confirm. So quiz 2 is on topics 4 and 5, and the midterm is on what topic?
Oh, midterm is on topic 2 and 3.
Oh, okay. I just wanted to confirm. So topic 2 and 3 is the midterm, and quiz 2 is topics 4 and 5.
4 and 5 is quiz 2.
Okay, perfect. Thank you. I just wanted to confirm.
All righty. Anybody else? All right, I'll take it as no. And then I will finish today's class a little early, so you can, study for the midterm and upcoming, quiz 2. So take care, everyone, and I will see you on Monday. Good luck with your midterm and quiz 2. So I'm gonna stop recording and sign out.